So today we're going to have a look at Unit 8.5, Angles in Triangles. Our objectives for today are to be able to calculate the interior and exterior angles in triangles, to use the rule for the sum of angles in a triangle, and to solve angle problems using triangles. Before we start, let's just check our prior knowledge. So we should know that angles on a straight line add up to 180 degrees because there are 180 degrees in half a turn. Should also know that angles around a point add up to 360 degrees because there are 360 degrees in a full turn, and we should know that vertically opposite angles are equal. So remember, vertically opposite angles are formed where we have two straight lines that cross over. At that intersection it forms four angles, and we have two pairs, so A and C, D and B are equal to each other, and we say that they are vertically opposite angles are equal. Make sure you're happy with those three rules before we move on. We will be using those during today's lesson. Okay, so we're going to start by looking at the interior and exterior angles in a shape then. So our interior angles are the angles formed inside the shape where the line segments meet. So in our triangle there we've got three interior angles, so interior on the inside. Exterior angles are formed when we extend the sides of our shape outwards. So if we extend those lines from our triangle, we can see that we have formed three exterior angles as well. So interior are inside the shape, exterior when we extend the sides of our shape, the angle that's formed between that extension and the original side of the shape form the exterior angles. Now, if we have an interior angle A and an exterior angle B, we can see that they lie on a perfectly straight line. So angle A plus angle B must add to 180 degrees because we know that angles on a straight line add to 180 degrees. So we can say then that the sum of one interior angle and one exterior angle is 180 degrees, and that is true for all of our different polygons, so many-sided shapes that we're going to be looking at. So one interior angle plus one exterior angle will always add to 180 degrees. Again, pause the video. Things in green boxes are important facts that we need to know, so please make a note of that in your book. Okay, so let's have a look at how we use that fact then to find interior and exterior angles. So we'll start with some examples. So we're asked to find the interior angle and the exterior angle for each of the shapes below. So for the first one then, the interior angle inside the shape here, we're told is 60 degrees. To find the exterior angle, angles on a straight line add to 180 degrees. So 180 minus 60 means the exterior angle is 120 degrees. For our second one, our interior angle, here we've got our little square symbol. Remember, that tells us it's a right angle, so our interior angle is 90 degrees. And our exterior angle, again, angles on a straight line, so 180 minus 90 is 90 degrees. For this one then, our interior angle here, well, we've got the exterior, so to find the interior, we've got our straight line, 180 degrees minus 80 will give us the interior angle of 100, and our exterior angle is 80 degrees. So remember, one interior and one exterior will always add to 180 because they are angles on a straight line. Okay, so now it's your turn. Pause the video, have a go at finding the interior and exterior angle for each of those shapes. Let's have a look then. So for the first one, our interior angle is 50 degrees. Our exterior angle, 180 minus 50, is 130 degrees. For B, our interior angle is 90 degrees, given by the right angle symbol, and our exterior angle, 180 minus 90, is also 90 degrees. For C, we've been given the exterior angle, so to find the interior angle, 180 minus 72 is 108 degrees, and our exterior angle was 72 degrees. Mark your work, make sure you're happy with that before you move on. Okay, so we're going to have a look now at the interior angles in our triangle and use those to help us. So the interior angles for a triangle add up to 180 degrees. So angles in a triangle add up to 180 degrees. So that's a fact that we should know. You probably know this fact already, but if you're not sure, do make sure you write it down. So how do we use this fact to help us then? So here we've got three different triangles. We've been given two of the angles in the triangle and we need to find the third. So to do this we need to add together the angles that we already know and take them from the total, which is 180 degrees. So 180 minus the 40 plus the 20. Again, remember, following BIDMAS we work out the brackets first. So 40 plus 20 is 60, 180 minus 60 means x is 120 degrees. For our second one, we're going to add the 45 and the 75 together, giving us 120. So 180 minus that total of 120 leaves us with 60 degrees. And finally, the third one, we're going to add together the 30 and our right angle, which is 90, which also gives us 120. 180 minus that total of 120 is also 60 degrees. Alright then, your turn. Pause the video, have a go at finding the missing angle in each of these triangles. So for A then, we should have had 180 minus the 40 plus the 60, which is 100. So 180 minus 100, which is 80 degrees. For the second one, we should have added the 70 and the 90, which is 160. 180 minus 160 is 20 degrees. And for the third one, if we add the 20 and the 30, that's 50. 180 minus 50 is 130 degrees. Check your answers with those. So our key point from this part of the lesson then is that the angles in a triangle add up to 180 degrees. Make sure you've got a note of that in your book. Okay, so when we're looking at triangles then, there are three types of triangles that we need to consider. So our first one here is called an equilateral triangle. The properties of an equilateral triangle is that all three sides are equal and all three angles are equal. Our second type of triangle is our isosceles triangle. So the properties of an isosceles triangle is that it has two equal sides and two equal angles, which are called the base angles. And our third type of triangle, the one we've been looking at so far, is called a scalene triangle. And in a scalene triangle, all the sides are different and all of the angles are different. Make sure you've made note of the different types of triangles and their properties. We're going to use some of those properties of those special types of triangles to help us to find more missing angles. So let's start with our equilateral triangle then. So we said our equilateral triangle, all of the three sides are equal, and we indicate side being equal with the short dashed lines. So these short dashed lines tell us that all those three sides are the same length, but also all of the angles are equal. So all three angles must be worth the same value. So if we know that the sum of the angles in a triangle is 180 degrees, and we know that all three must be exactly the same size, we do 180 divided by 3, each angle is 60 degrees. So in an equilateral triangle, every angle is 60 degrees. So again, this is a fact that we need to learn. So when you're given an equilateral triangle, you may not be told any of the angles on the inside. You need to know that they will always all be 60 degrees. Okay, so our second special type of triangle then is our isosceles triangle, and this is the one where two of the sides are equal and the two angles at the bottom of the equal sides are called the base angles, and they are also equal. So we follow down the sides that are the same, and at the bottom of those equal sides is where we find the base angles. Now base does not mean at the bottom of the diagram. So these are also isosceles triangles, but we can see that our base angles this time are at the top. So again, we've had to follow down along the two lengths that are indicated to be the same length to find the base ones. And in this one, again, these ones are at the side. Okay, so don't be convinced that it's always the two at the bottom of the diagram. You need to make sure you follow along those two sides that are the same length, and it's at the end of those two lines you'll find the equal angles. So if we're told one of the angles in our isosceles triangle, we can work out the other two. So we're going to have a go at that now. So here we go then. Example 1, we're asked to find angles A and B and give reasons for your answers. Remember, giving reasons simply means to write down the rule that we used to work it out. So we can see we've got an isosceles triangle. If we follow down our two lines that are the same, then these must be the base angles. So A must be 65 degrees because base angles in an isosceles triangle are equal. So that's my reason, the rule that I used to tell me that that angle was 65 degrees. Once I know two angles in a triangle, we can work out the third. We know that all three must add to 180 degrees. So 180, take away the 65 plus A, which is also 65, means that angle B is 50 degrees. And the rule we used there was that angles in a triangle add up to 180 degrees. Okay, our second example then. We're asked to calculate angles X and Y, and again give reasons. So again we can see we've got an isosceles triangle. We follow down the two sides of the same length, so these X and Y are our base angles. So we know that all the angles in our triangle must add to 180 degrees. So if we do 180 minus 130, we get 50 degrees. So that means angle X and angle Y together must equal 50 degrees. Okay, so 180, take off the one angle we know, means that the value we're left with must be shared between the two angles at the base this time. We know they have to be equal, so if we do 50 divided by 2, that gives us angle X at 25 and angle Y at 25 degrees. And our reason, the base angles in an isosceles triangle are equal. So we've got two different examples there. One where we're told one of the base angles, we need to find the other two, and one where we're told the other angle and we need to find the two base angles. Okay, pause the video, make a note of those examples, that will help you with your questions later. Okay, our third example then. Again, we're asked to find angles X and Y and give reasons for our answer. So here we can see we've also got an isosceles triangle. It's got the two dashes to tell us these two sides are the same length. So following these up, our base angles are here and here. And we've also got an extended line producing an exterior angle, which we've called X. So we're going to start off by finding that exterior angle. So we've got our straight line along the bottom, so we know one interior and one exterior must add to 180 degrees. So 180 minus 54 means X is 126 degrees. And again, the reason we used was that angles on a straight line add up to 180 degrees. Now I'm going to find angle Y. So we've said that Y and this other angle here must be the two that are equal to each other. They're the base angles. So our two base angles are 180 minus 54 are 126 degrees between them. So that's shared between Y and the other angle over here. Our reason, angles in a triangle add up to 180 degrees. So now to find Y, we need to divide our answer into two equal parts. So 126 divided by 2 means that Y is 63 degrees, and our reason, base angles in an isosceles triangle are equal. So you'll notice for each angle that I found, I've given the reason, the rule I used to find that particular value. So every time we find a value, we have to say which rule we've used. Okay, make a note of that example, and then we're going to move on to having a go. Okay, so there are 5 questions there then, so pause the video, have a go at finding the angles marked with the lowercase letters. Alright, let's have a look then at the solutions for these. So, angle A then, so an isosceles triangle, so we follow our 2 lines down, so these must be our base angles, so A is 55 degrees, base angles in an isosceles triangle are equal. Again, we've got another isosceles triangle, so we're going to follow our 2 lines, so these 2 must be the base angles, so B is 70 degrees, base angles in an isosceles triangle are equal. Another isosceles triangle here, if we follow the lines down, C and D are both base angles. So we need to start by taking 50 away from 180. So C plus D as 180 minus 50 is 130. And we used angles in the triangle add up to 180 degrees to work that bit out. So both of these together are 130. So we need to share those equally by dividing by 2. So C and D are both 65 degrees each. And the rule we use with base angles in an isosceles triangle are equal. Down here then, we've got another isosceles triangle, so again, following our 2 lines. Our base angles are these 2, so T must also be 45 degrees, base angles in an isosceles triangle are equal. And once I know 2 angles in the triangle, add them together and take them from 180, which leaves me with U as 90 degrees. Angles in a triangle add up to 180 degrees. Finally then over here, we've got our isosceles triangle, but we've also got an exterior angle as well. So let's start off with A. So if we follow the 2 lines of our isosceles triangle, we can see that this one here and A are both base angles. So A is 40 degrees, base angles in an isosceles triangle are equal. Once we know A is 40 degrees, we've got one interior and one exterior angle on a straight line, so we know they add to 180. So 180 minus, I don't know why it says 40 plus 40, that's exciting. Sorry about that, slight typing error there. So 180 minus 40 equals 140 for B. Angles on a straight line add up to 180 degrees. Okay, hopefully you've got all of those right. Alright, finally then we're going to have a look at our challenge question. So remembering our key point from this part of the lesson is in an isosceles triangle, the angles at the base of the equal sides are equal. So we're going to use that again to help us. So we're going to try and calculate angle X, which is over here, okay, using the shapes we've got. So the hints are we will need to find other angles first, and we should be looking to see which type of triangles the drawing is made up from. So pause the video now, have a go, see if you can work your way around the shape to find the value of angle X. Okay, so let's have a look at how we can solve this problem. So down here we're told this angle is 44 and we've got an isosceles triangle here. So we know that our 2 base angles, so if we follow our equal length lines, the base angles are here and here. Okay, the 2 base angles must be equal to each other. So if we do 180 minus 44 and then divide the answer by 2, that will give us our 2 base angles, which are both 68. Now we need to use some of the other rules we know. So here we've got 2 straight lines that form a cross, so we've got vertically opposite angles. Vertically opposite angles are equal, so this angle here is also 68 degrees. Now here we have another triangle. This is a scalene triangle. I know it's a scalene triangle because it hasn't got any marks on it at all to tell me any of the sides are the same length. So we're going to use our normal angles in a triangle rule of adding to 180. So 180 minus the 53 plus the 68 gives us our third angle of 59 degrees. Again, we've got our two straight lines forming across, so we're going to use vertically opposite angles are equal. So this angle here must also be 59 degrees. And finally, our last triangle is isosceles. We can see this length here and this one here are identical. So these are our base angles. So our other base angle, 59 degrees. And to finally find angle X, then if we do 180 minus 59 plus 59, angle X is 62 degrees. Well done if you managed to work your way across the diagram and find X as 62 degrees. Okay, well thank you. I hope you found this lesson useful today. Please click on the link to move on to the next lesson when you're ready.